Hi everyone, this is Himanshi. Today I am going to teach you maths and I'll be taking the polynomial chapter for this session. The flow of this chapter will be in such a way, we'll be discussing the terminologies of polynomials, then we'll be going to the types of polynomials portion, and then we'll be discussing some examples based on these terminologies so that it will be more clear to you that what those terminologies mean, and we'll end up the session with that only. Okay, so let's start with this polynomials. What do we mean by polynomials? Before starting with this, let us be more clear with the word algebraic expression. Algebraic expression. Why? Because we know that polynomials is part of what? Algebraic expression. So first of all, taking a look on algebraic expression. Algebraic expression is nothing but a mathematical expression which contains what? Some variables, constants, and those variables and constants are joined by what? Some mathematical operations. So let us start with the general form of what? Algebraic expression. So general form is what? A to an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2, and so on goes till what? A naught x to the power 0. Okay. So this is the general form of algebraic expression. Now let us understand with the definition. So what is an expression? An algebraic expression is a mathematical expression which contains some constants, some variables, and some mathematical operations. So here these all a terms, that is an minus 1, an minus 2, and so on till a naught. What are these? These are constants. I'll tell you in a minute what are constants and what are variables. First of all, just to see the symbolic meaning of all these. An mean an minus 1, an minus 2, a naught, all these are what? Constants. And x to the power n minus 1, or all these written here, x to the power 0, all these are what? Variables. All these are what? Variables. We can use it without these powers also, or with these powers you can write x denote here what? Variable. And you all know that these plus signs are what? Mathematical operations. Now let us be more clear with what do we mean by variables and constants. Variables means those values which changes continuously, which do not remain same. And what is constant? Constant means what? Vice versa of variable. That is, which value remains just the same as it is for its whole life. Like suppose 2, 7, 8, 10, all the numbers in this world are what? Fixed in their proper, fixed in their proper values. 2 equals to 2 means 2. Okay, so it is a constant, it does not changes. Okay, but now suppose I want to find the area of a rectangle. So what do I require? I require length, I require breadth, and each time the length and breadth, what it does, it changes. Each time the length and the breadth, what it does, it changes, because every time the dimensions cannot remain same. So what is we denote the area like this? A equals to L into B. What are we writing? We are writing two alphabets and showing that these two values does not remain same. So you can put any value each time you have a different value, you can put those values here. So this is not a fixed one. You can replace it every time you have a different value. So L and B are what? These are variables. These are not fixed values, these changes continuously. So variables are represented by alphabets. This you have to remember. Okay, so we are clear with the variable word, what is variable, and we are clear with constants also. And what are mathematical operations? Mathematical operations are plus, minus, multiply, and divide. Now what is the definition? An expression with variables, constants joined by some mathematical operations. Now see here, we have these constants. We have constants in our expression, yes. We have variables in our constant, yes, and we have operations in our given expression. Hence, this is a general form of an algebraic expression. Now, one thing you have to remember is this an can't be 0. Why so? Because if an becomes 0, then this whole value whole value will get what? Equal to 0. Why? Because all these values are hiddenly joined with a mathematical operation, and that is the multiply sign. Between these two, a hidden operation is there, and that is what? Multiply sign. Because this whole constitutes what? A single term. This whole constitutes a what? A single term. So in a term we write everything in multiply form. In a single term we write everything in the multiply form. Like suppose I have written here, I am writing an expression 3abc. I am writing an expression, an algebraic expression 3abc, where 3 is a constant. It is very much clear. ABC are the alphabets, hence these are variables. So this is an algebraic expression. Here, can we see any sign in between? No. Multiply sign is hidden in between these. If I write the expanded form of this, it becomes 3 into A into B into what? C. So in this way, where the signs are hidden, that means multiply sign is given there. So you have to remember, in a single term, what sign is given? Either multiply or divide sign will be given. Now, how to identify terms in an algebraic expression, or what do we mean by the word term? This is a very important term. This is a very important word, terms. So we need to understand what do we mean by term. Now see here, suppose I write an algebraic expression. Here, 3xy square z plus 5xy square plus 5, 6, 2, 1 xy. Now suppose I have written an algebraic expression here. Okay. Now we have to identify terms. How do we identify term? Term is a portion of an algebraic expression separated by either plus or minus sign. What is a term? Term is a portion of an expression which is separated by either the plus sign or a minus sign, not by multiply, not by division sign, either by plus or minus. This you have to make it clear in your mind. Okay, so how do we identify term? Term is a portion. Now see here, plus, here it is given, here it is also given plus sign. So that means this portion, and this portion. We have three portions in our algebraic expression. So first portion is 3xy square z, second portion will be the 5xy square, and third portion will be 5, 6, 2, 1 xy. Okay, clear hai ye baat? Now 3xy square z is a what? A term. This is a term 1. This is what? Term 2. This is what? Term 3. Okay, so am I clear with the word term? Term will always be identified where we have plus or minus sign, not the multiply or the division sign, because multiply and division sign will always be hidden. So you can easily identify how many terms are there in our algebraic expression. Okay. Now see, we have three terms in our algebraic expressions. Now can you expand and write this term? We can write this term as 5, 6, 2, 1 into x into y. So here comes another word, that is coefficients. Now we have to be well versed with the word coefficients. What are coefficients? Coefficients means the value written before something. Now suppose I say, what is the coefficient of xy? Suppose here I say, what is the coefficient of xy? So you have to find the term which just contains what? Xy, xy. So here I have xy square, here I have xy square z, and here I have xy. So I have asked you, what is the coefficient of xy? So that means you just have to see the xy part and not other than that. So what are coefficients? Coefficients are either the numerical part or the variable part. That means either the constant or the numerical part. Okay, so for finding the coefficient, you have to first identify a term. For finding a coefficient, what you have to do? You have to first identify the term in which you have to find the given coefficient. Okay, so I am asking you, find the coefficient of xy. So first you have to identify which term am I talking about, or which term consists xy. So first identifying the term, then finding the coefficient. So xy is in the third term. So we will get our coefficient in the third term because xy is given in the third term. Other terms have xy square z, xy square. Okay. So now what is the value of coefficient? Coefficient is the part written before it. So what is written before xy? Xy is 5, 6, 2, 1. So the coefficient of xy will be what? 5, 6, 2, 1. This will be your answer. Now suppose I ask you find the coefficient of xy square z. I ask you find the coefficient of xy square z. So first what will you do? You will identify the term which contains xy square z in your question. You will see the which term contains xy square z. So our first term contains xy square z. Now what we have to do? We have to find the coefficient of it. So what is written before xy square z? 3 is written before xy square z. Is that clear? Is it clear or not? So how will you find the coefficient? You will find the coefficient after identifying the term and then find the coefficient. Just identify the front part of that term. Okay. Front part, not the front part, the part which is written before the asked part. Okay. Now let us understand what is the difference between algebraic expression and polynomial. So coming on to the next part, what is the difference between algebraic expression and polynomial? See, I have written the general form in this way, like a n x to the power n minus 1 plus a n minus 1 x to the power n minus 2 plus a n minus 2 x to the power a n minus 3 x to the power n minus 3, and so on it goes till x naught and a naught. Okay, so see here what is given. A n x to the power n minus 1, this is the power of x, and I'm writing this is n, this is n, right, this is n, and this becomes 1, this becomes 2, and so on, the power gets decreased. Now writing in an expression, in a mathematical expression form, similarly 5 x to the power 7 plus 4 x to the power 6 plus 21 x to the power 5 plus 30 x to the power 4 plus 25 x to the power 3 plus 26 x to the power 2 plus x to the power 1 and plus 5 x to the power 0. Now suppose I have written the general form as well as the general form and the mathematical form also. I have written both the forms. I have written here. Now compare these two. 5 comes in place of a n, x to the power comes in place of x to the power n. Now so on, see here the power gets decreased continuously. The power gets decreased continuously. So this is the way of writing an algebraic expression always, so that our question will come in which we have to find the degree of polynomial. Our question will come in which we have to find the degree of the polynomial. So we can, it is useful there that we have to write the power in the decreasing order or either in the increasing order. So it will be easy for us to calculate the degree questions. Okay. So what you have to do, always write an algebraic expression in the decreasing power, of variables. X are what? X are variables, and all these are written are what? Constants, and these are joined with what? Plus sign. That means all these are terms. So how many terms do we have in this question? 1, 2, 3, 4, 5, 6, 7 and 8 terms. So total we have how many terms? We have 8 number of terms. Clear? Now 5 and x to the power 7 is joined by what? Multiply sign. This you can identify easily. 5 into x to the power 7. So what is the method of writing an algebraic expression? You have to write always in the decreasing order of the power or in the increasing order of its power. So you can write either start from 5x to the power 0 or you can start from 5x to the power 7. Okay. Now what else do we have to know about it? What is the difference between algebraic expression and polynomial? Okay, now see here, x to the power 7, x to the power 6. In an algebraic expression, any variable can take any value, any power. Any variable can take any power. Okay, now see here. Here we have a positive power, here also we have a positive power, here also we have a positive power, but we can take n can be equal to any number. N can be equal to any number. It can be a root value, it can be a positive integer, it can be a negative integer, it can be 0, it can be any number. In an algebraic expression, a variable can take any power. A variable can take any power. But here comes the difference between algebraic expression and polynomial, is that in an algebraic expression we can take any power for a variable, but in a polynomial we can just take only and only positive integers and 0. Or I can say in an easy language, all the natural numbers can be used as a power for a variable in a polynomial. We cannot use negative power, we cannot use fractional values, we cannot use root values, we can just use a positive power. We can just use 0, we can use natural numbers for the variables for its power. Okay, now see here, suppose I write 5x to the power minus 75. So this is not an polynomial, it is just an algebraic expression. Because in an algebraic expression, what do we get? We just get a power which can be a root, which can be negative, which can be positive, which can be any value. But in a polynomial, we just take natural numbers and 0. Or in an easy language, we can write as whole numbers. So what do we understand now? In a polynomial, only whole numbers can be used as a power for variables. We cannot use any negative power, we cannot use any fraction power, we cannot use any root power. And in an algebraic expression, any power can be used. So every expression is an algebraic expression, but not every algebraic expression is a polynomial. Is it clear? Hence it proves that polynomial is a part of an algebraic expression. It is a part of what? An algebraic expression. So am I clear with the power concept, that we have to use the positive power only? Now suppose I am giving you a question, 3xyz plus 5xy square upon 3x. Now suppose I am giving you a question here, a 3xyz, I think so. Okay. Now see, here it is an example. Is it an algebraic expression? Yes, it is an algebraic expression because it has variables, it has constants as well as the mathematical operations. Okay, but is it a polynomial? This we have to check. Now see, what will we do while we check a polynomial or an algebraic expression validity? We have to see the powers of the variables. Just the powers of the variables, we'll get to know whether it is a polynomial or it is an algebraic expression. Now see here, we have 1 here, we have 1 here, we have 1 here. No power means 1 is given. So we have 1x here and 2y here, and here also 1 and 1. Now, can we write this as 3xyz plus 5xy square separated by 3xz? Can we separate the denominator? Yes, we can. We can write the denominator under both these terms and we can form two separate terms of an algebraic expression. Now can we cancel these two? Yes, we can cancel. X gets cancels. Okay. Now what do we get here? Here we get y, and here 5y square upon 3z. Now can we write like this? 5y square upon 3 into z to the power minus 1. Can we write like this? Yes, we can, because the variable given in the denominator has power plus 1, and when it comes in the numerator it gets equal to z to the power minus 1 or z inverse. Okay, so now this is our reduced form of our algebraic expression. This is the reduced form of our, or an open form of our algebraic expression, so that it is more clear what is happening in this. Okay, so see here we have y with the positive power, that is plus 1 power. Here in this term we have a y with the positive 2 power, but we have a variable z which has a negative power, This shows that this algebraic expression is not a polynomial. Before, originally when this example was given, you were able to see that all the powers were in the positive form because this was written in the denominator. But to clarify whether it is a polynomial or an algebraic expression, what we have to do, we have to solve it and we have to see whether all the variables have positive power or not, whether all the variables have the power as the whole numbers or not. So here we can find that x and z were in the denominators, hence they'll go in the numerator part and will have a negative power. We can check directly also. I have shown you in the long method so that it is easier to see what is happening. Now see the easiest part. How can we solve this easily, or how can we identify this easily? 5xy square upon 3xy. Now see here, 3xz. Now see here, 3xyz, we know that this can be separated, so easily this x gets cancels out with this x, and this x also gets cancels out with this x, because this is common for these two and these both terms have what, x in their terms, hence x can be cancelled. Okay, now 3, what remains is 3yz plus 5y square upon 3. Still we have z without being cancelled in the denominator, hence this will create a problem for an algebraic expression, making it a polynomial. So z will have a negative value, hence we can declare from here, from this step only, that we have a variable with a negative power, hence this algebraic expression can't be called as a polynomial. Am I clear with the concept that how to find algebraic expression, or how to check whether an algebraic expression is a polynomial or not? Am I clear? Okay, now let us understand what are the types of polynomial. What are types of polynomial? Now see, polynomials are divided on the basis of two cases. First one is based on the number of terms, and the second part is based on degree. This we'll discuss later, degree part we'll discuss later, and first we'll be coming on to the terms part. Now I have told you that how do we identify the terms in an algebraic expression or in a polynomial. The portions which are separated with plus or minus are known as what, terms, and we can calculate easily the number of terms in an algebraic expression. Now what we have to do, we have to bifurcate polynomials on the basis of number of terms. So if a polynomial has one term, then it is called as monomial. If a polynomial has two terms, then it can be called as binomial. So these are the types of polynomial based on the number of terms. If we have 3 terms, then we'll call it as trinomial. And similarly, if we have n number of terms, or if we have many number of terms, then we'll call it as we know, it is a name given only, polynomial. Okay, so polynomial means many number of terms. Polynomial means many number of terms. So we can in this way we can do the bifurcation of the types of polynomials in two, that based on the number of terms and based on degree. So if we have one term in an algebraic expression, we'll call it as a monomial. 2 terms means binomial. 3 terms means trinomial, and many number of terms, if they are included or more than 3, we can call it as a polynomial. Clear? Okay, now see, based on degree. So for this we have to understand what do we mean by the term degree. So next terminology comes here is degree. Let us understand it. Now see, how do we calculate degree of a polynomial? Now see, suppose I am giving an example, 520 x square y square z plus 35 xyz plus 50 xy. Now how do we calculate the degree of a polynomial? First step to calculate the degree of the polynomial is to identify which term has maximum number of variables. First step to calculate the degree is check which term has maximum number of variables. Now see here, we have three terms in our algebraic expression in this given example. We have, this is our first term, this is our second, and this is our third term. Now what do we have? Is it a polynomial? Yes, it is a polynomial. How can we check? All the variables are in the numerator, hence they have what? The whole number as their powers. So it is no problem for us to see it is a polynomial or not. Okay, so this we have verified. Yeah, we are calculating degree of a polynomial and as well as what? Algebraic expression, because every polynomial is what? Every polynomial is a algebraic expression, but not every algebraic expression is a polynomial. Like see one example of algebraic expression which is not in a root form. See an example. Sorry, 36 root xy square plus 56 xy to the power minus 3 by 2. See here, can we write the format? Can we write the format in the power form? Like see, can we remove this root? Yeah, we can remove. 36 xy square whole to the power what? Half. Whole to the power what? Half. Root, when we remove the root, we use power as half. We use power as half. And what is the remaining part? Xy to the power minus 3 by 2. So this is an algebraic expression which is not called as a polynomial. Is it clear? Because here we have a fractional power, a negative power, which is not a whole number. Hence this algebraic expression is not a polynomial. So is it clear? Is it clear with the part of understanding whether it is a polynomial or algebraic expression? Okay. Now see here, coming on to the topic, that is degree of polynomial. What is given here? First step you have to do is check that term which has maximum number of variables in it. Check that term which has maximum number of variables in it. Now see, here we have 2x, 2y and 1z. That means 5 variables are there here. 3 variables are here and 2 variables are here. So we choose this as our main term which has maximum number of variables. Now count all the number of variables. We have 5 variables. So this becomes our degree of polynomial. So degree of polynomial is what? 5. What is degree? Now I'll explain in a typical language, because we have understood in the easy language. Degree is what? It is the highest power of variable. Highest power of a variable in a term. Highest power of variable in a term. Okay, so what is the highest power given here? Each term we have checked, we found that in the power of variables we can add. So in the first term we have 5 variables, in our second term we have 3 variables, and in our third term we have 2 variables. So what will be the degree? Degree will be what? The highest power of the variables. So in a single term we add all the parts of the variables. We add all the parts of the variable. Here we have 1 as our z power, so we can add all this and we can get what? The degree of the polynomial, because this term contains maximum number of variables. So what is degree? Degree is the highest power of variables. Highest power of variables in a term. So what we have to do? First we have to identify which has maximum number of variables. Then we have to calculate what? We have to add all the powers of the variable and we can get what? Degree of the polynomial. So what is the degree of polynomial? Here we have 5 as our degree. Now let us take another example for calculating degree. Let us take another example. See here, 3x square y z cube plus 4xy square z की power 4 plus 78x to the power 5y. Okay, so this is our question in which 3 terms are given. What we have to do? We have to find the degree of the polynomial. So we'll identify which term has maximum number of variables. So here we have 2, 1 and 3, 6 variables. Here we have 3 plus 4, 7 variables, and here we have 6 variables. So this term we choose, and here it is 7 variables, hence degree becomes what? 7. So this is the way to calculate what? Degree of the polynomial. Now based on this degree we'll be calculating what? We'll be discussing the types of polynomials based on degree. So if the degree of polynomial, if the degree of polynomial is 0, then we call it as 0 polynomial. Then we call it as zero polynomial. If the degree is 1, then we call it as linear polynomial. Linear polynomial. If degree becomes 2, then we call it as quadratic. Then we call it as quadratic polynomial. And if the degree becomes 3, then we call it as what? Cubic polynomial. And so on the name goes. So you just have to remember zero polynomial, linear polynomial, quadratic polynomial, cubic polynomial, and so on. The power increases and the name changes, but you just remember these 4 because this will be in the use for your this will be mainly used in your course. Okay, so one more polynomial comes here is the constant polynomial. Constant polynomial, this also we'll discuss later. In this, now we'll start with the zero polynomial, how the degree of polynomial is 0, how the degree of polynomial is 0. Now see here, I'm writing like this an expression 3x square plus 5. Now can you explain me what is written here or what is hidden? What is hidden here? Here can we write like this, x to the power 0, y to the power 0? Can we write like this? Yes, we can write like this, because anything raised to the power 0 gives what? 1. Anything that raised to the power 0 gives what? 1. So can we write x to the power 0, y to the power 0, m to the power 0, z to the power 0? Any power 0 can be written here. So in this we have two terms, and in each in the first term we have two variables, that is 2x, and in the last term we do not have any variable. That means if there is no variable, there will be no degree, because for a degree you need to have what? You need to have variables. Okay, so the degree of this polynomial can be calculated as how can we calculate the degree of this? 3x square plus 5x to the power 0. Now we have to check whether we have how many number of variables which have highest number of variable. So here we have 2 variable and here we do not have any variable, hence the degree of polynomial becomes what? 2. Degree of polynomial becomes what? 2. So can we write or can we call 3x square plus 5 as a quadratic polynomial or not? Can we call 3x square plus 5 as a quadratic polynomial or not? Because it has degree what? It has degree 2. Okay, it has degree what? 2. Now understanding what is a constant polynomial, what is a zero polynomial? Nothing but 0. 0 is called as a zero polynomial. Only 0 can be called as a zero polynomial, because zero polynomial has degree what? Undefined. Has degree what? Undefined. Let me clear that topic. One second. Here, sorry, I have written as zero polynomial as the example. Sorry, replace this degree with undefined. This is undefined. Degree of zero polynomial is undefined. It is not 0. 0 is the zero polynomial. I have written that 0. So degree of zero polynomial is what? Undefined. And degree of constant polynomial is what? 0. This I am explaining in a next minute. In the next minute I am explaining. So see here. Zero polynomial degree is undefined. How can we calculate this? I have told you that zero polynomial example is 0. 0 is called as zero polynomial. The only zero polynomial in this world is 0 itself. Now see, we have to check what? Degree. We have to check the degree of this polynomial. Now this polynomial is written like this, and can I write like this? X to the power 0, x to the power 5, x to the power half. X to the power half can be written? No, because it is a polynomial, so we can't write x to the power half because it is a fractional value. Can I write like this? X to the power minus 3? No, because it is a polynomial. I can't write this. So removing all these two, because I am talking about what? Polynomial. Okay. Now can I write like this? X to the power 0, x to the power 5, because anything multiplied with 0 will give you what? 0 itself. So I can write like this. Okay. Now see here. Can I identify what is the degree? Because here anything can be written. Anything can be written. X to the power n, x to the power n minus 1, x to the power y, anything can be written. So is the degree of this defined? Is the variable part defined here? How many number of variables do I have in this 0 polynomial? No. Hence this degree answer comes what? Undefined. That we cannot define the degree of a 0 polynomial, because any number of variables can be written in front of 0 and it will give what? It will give us 0 only, because anything multiplied to 0 will be what? 0 itself. So we can write anything here. So it means that we cannot define the number of variables in this polynomial, hence we cannot calculate the degree, hence the answer comes what? Undefined. Is it clear? Okay, so what you will remember, that the example of 0 polynomial is 0 itself, and what is the degree of 0 polynomial? It is undefined. Okay, is it clear? Now coming on to the constant polynomial. What is constant polynomial? Constant polynomial means, देखो, we can write a polynomial in this format: polynomial in terms of x. We will be using variable x. Polynomial in terms of x can be written as px equals to 0. Okay, now see, constant polynomial. I am writing 26. Is it an algebraic expression? Yes, it is an algebraic expression, because I can write like this: x to the power 0, m to the power 0, a to the power 0. It contains variables, it contains constants, and it contains what? An mathematical operation, a mathematical operation. So can I say it is an algebraic expression? It is a polynomial. Yes, I can definitely say 26 is a polynomial and it is an algebraic expression. Now what do we have to see? We have to see the degree of the polynomial. For degree we have to identify the maximum number of variables in that polynomial. So see here, I can write infinite number of variables, sorry, x to the power 0, no, this becomes m to the power 0, a to the power 0, z to the power 0. I can write any number of power to the 0, any number of variable raised to the power 0. Okay, so this says what? That I can write any number of variables with power 0, because this will give what? 1, and 1 into 26 will give me what? 26. So I can write in this format also. Now can you find the number of variables in this term or in this expression? Yes, I can see that there are no variables, because each variable has power 0 on it, which means that that does not exist. Hence in a constant polynomial we do not have any variable, which means degree of that polynomial becomes 0, because we have no variable, we have 0 variable. Hence degree of constant polynomial is what? 0.